So we have seen these two methods in the, let's say, previous part number 4, and now we are going to see how to translate the other part of the speech, actually the translated speech. Here, for that, we need to call the ElevenLabs API key to begin with. So here, ElevenLabs API key equals to os get.getEnv, and here of course we need this again. So this is it. This is how we need it. And now we also need to instantiate the client, which is client right here equals to ElevenLabs this method, and use the API key, of course. So now what we are going to do is to write a method which is able to generate text-to-speech with dynamic speed. I've talked in the end of the part number 4, if you remember, about why we need to vary the speed. So for this, we write this method generate TTS with dynamic speed, and here we need text as input, the voice ID. Then we need also the target duration in milliseconds. Why we need this? Because as I have shown you, we do have this difference. So you can imagine having for each sentence a start and an end. The difference between both is the target duration for the given section. Then we have also in ElevenLabs, they provide a minimum speed of speech, which is around 0.7, and the max speed is at 1.2. So there is the possibility to accelerate and decelerate, but since decelerating is a little more computational expensive, so you can imagine having in a first step you can start at speed equals 1, then compare. Then step 2 would be to compare the speed or given the result duration versus target speed. And then also you need to either accelerate at a given step or decelerate. And for this, you need to also the comparison here should be a little accurate, because sometimes you do have very tiny differences, and this could be also misleading. I personally avoided this because, in my opinion, this is a little more computationally expensive. You can try it on your own. What I've done here is simply to take the speed equals to 1.0 and the step equals to 0.1, and going either upwards or staying at 1. So I equals 0 is the first step, and we need, of course, some temp file equals instantiated first of all to none. You can also begin with basically with min speed here. I've tried this also, but if you get stuck at 0.7, the speech quality could be very, very bad. I recommend you to visit the ElevenLabs website and see their comment on what they think about or how they perceive their own API or let's say AI speech generation efficiency, and how they criticize or how they warn the user about using very low speeds at generating the speech. This being said, let's now jump in. So we need to compare the max speed with the actual speed. So we need for this a while loop, and this speed is while speed equals to max speed. We need to we need to at least run this. If you use, I don't know, if you use, let's say 008 or anything like this, you would love to run this. And for this, let's take speed and 2. Then the temp file would be ftts temp I, and this is of course that mp3. Then we will try also to convert the text to the speech. Audio equals to client dot text to speech. Okay, so this is you can choose between to dialogue, to sound effects, to speech, to voice. For me, I used to speech. If you need to try something else, feel free. And then what is necessary is also to convert. Just use convert. You can also convert with timestamps, but this would be expensive. So you will you will use your whole credits or a lot of your credits, because you not only generate speech but also tokens, and this is also not for free. So it's up to you. I will show you later on how to use Whisper again to get the translator text from the generated audio. So and then what we got here is text equals text as input arguments. Then the voice ID, which is you need your voice ID. We will talk about this later, how to eventually clone something. Then model ID equals to here the model is 11 multilingual v2. You can use also the output format. The output format, you can find it here in the documentation, mp3. So I've chosen this 128 kilobytes. Then, of course, also you need the voice settings. The voice settings is something that you can experiment with. Also, voice settings is you have here something which is, I forgot the comma. Okay, so you got the stability equals 0.75. The similarity boost equals to also 75%. The style, you can play around with these parameters. To be honest, I didn't really experiment, but as long as this worked for me, this is fine. Also, the thing is here, you should consider being aware aware that experimenting with these different setups cost you money. This is why I didn't make really a huge deep dive in this. And but as I said, you can always try everything you want to and see what suits your use case to the best. So now we will print exception. Hopefully we won't have this exception, but this is something you should also consider at speed. And then here you have the speed, which is here. Then you got this E. Then we will break here. And then what we need also is to write the temp file with open temp file, which is an audio file, in order to save the generated segment or voice or speech segment. And yeah, so this is for chunk in audio. We will write the chunk. This is hopefully straightforward. Then we actually also need to get the duration in order to compare. So the duration is equal in milliseconds. We basically need to know what is the let's say the duration of the generated audio in order to be able to compare generated duration in milliseconds. And here we got our temp file. So this is it. Now what we got also, if duration in milliseconds is less than target duration in milliseconds, we should return the temp file and the speed. So I need to write this method actually. So this get duration before going further. So you can imagine having get audio duration in milliseconds, file path as an argument. So what is here necessary is to use FFmpeg again in order to FFprobe, sorry for this, in order to be able to get the duration. So result equals to, I don't know if we've imported some process, import sub process, then we can use it here again to run the command, and sub process.run. And what we've got is a list of arguments. So FFprobe, then comma, we got the V, we got also the error, and show entries. We also get the format equals duration. We also have this argument off, and in the end we got default equals no print wrappers equals 1, no key equals 1, and here we got the file path. We also for the sub-process method, we need to specify the capture output equals to true and text also equals to true. Then we also need to, so duration is derived right. Like this, duration result dot stdout dot strip, and we will return the integer of the duration times 1000, because this is in order to get the milliseconds. So you can always, of course, use other methods, and this has at least worked pretty well for me. And then what you also need to do, we can also here go back to the duration milliseconds, and then what we also need to do after this is to remove the last temp file, and if last temp file and os dot path that exists of the last temp file, we can remove the last temp file. And also, of course, here this is specific to every it's basic to every loop. If you remove the last temp file, takes the actual temp file before it's done, and then you need to speed up if necessary. If this is this is not done, and of course I takes another step, I plus 1. You need to actually increment this. Then, in order to be to visualize and get an idea or a feeling of how this has been proceeding so far, you need to make something which is like no speed under let's say, so we want to print this, yeah, exactly. So this is no speed under max speed produced a short enough output using final attempt at speed max speed. And you can also return last temp file and also max speed. So this is what we need in the end, because step. So this should be a step, and this is actually what. We didn't use min speed. I put it here though because if you ever want to use it, you can feel free to do it. I simplified this version, and this is acceptable for me, but I just want to give you an intuition or the idea on how to use this method actually, because otherwise ElevenLabs won't have a feeling for you or won't adjust automatically to your to respect the time segments you have, or let's say the duration segments you got at your disposition. Okay, so this is now done. What we need is to take then something for the bigger picture, takes text to speech from segments. And then here, this method would be an element used in this one. So what we need is, of course, the segments path, and which is actually, we have extractions. We got also the translated segments .json. Then we need also to have the voice ID, which is for now empty. Afterwards, we need the output audio, which is also the let's say extractions. We will name it translated audio. So output audio would be extractions again, the relative path, and then translated audio .mp3, and this is it. So we will also need to have some combination. We will initialize combined using audio segments, because we will concatenate in the end the audio segments. So audio segment.empty in order to initialize previous end equals 0. And this is specific to know whether, because we have said that all actually our timings or timestamps start could not necessarily match the end. In this case, it matches the end very well, but sometimes it doesn't. This could be 340, for example, and this could be 341. And since then, it's of course very necessary to be able to track, or at least fill the gap and detect the previous end in order to be able to build upon this. And this might also cause some disproportion with regards to the speech video, but this is also minimal. I mean, it happens also in real life. It's not necessarily the case where the speech matches exactly the movements of the lips or anything like this. If you need to have such a great quality, you need to really, really deep dive in the smallest details of this implementation. Now for this, I also need to emphasize that I think in this case, as I've shown you, I didn't encounter any disproportion between the speed and end here, start and end, which is bad luck for the demonstration, but you could, I'm sure that you can have it, since I have had the case. And we basically try to not only mention the perfect case. You don't know what Whisper outputs. So now back to previous end. Here, what we've got is something to begin with. We need to open the segments. With open segments path, we need to have the read mode and of course the encoding here is equal to UTF-8, then it is also necessary to have no, this is enough as file, and then the segments would be equals to JSON that load the file, and then we also need to of course know generate or extract get text. So for this we going to use enumerate for I segment. In enumerate segments, and what we got here is the text equals to segment and get the text in French. Here we suppose that we have only one target, but we can generalize. We could use another dictionary to avoid the generation or the confusion. But this is now for this tutorial more than enough. And the start, we need to also get the start float number of the segment.get. Also, what we got here is a start and 0 elsewhere, and end should be also a float number of which is the segment.get, and here we got an end. And also for security we put otherwise 2 seconds difference, and the target duration is target duration is equal to, in milliseconds of course, is equal to int, and this is start minus end, and of course times 1000. So all right, here we got many use cases. We need to have a little patience. So let's suppose that the start, if start, the case that I've mentioned, if start is more than previous end. So here what we got a gap duration in milliseconds, which is equal to the integer of start minus previous end, and times, of course, the 1000 here, and then we print something like this, inserting the gap duration milliseconds of silence before segment I, which is I plus 1, combined, then here combined, plus equal audio segment dot silent. So we are adding some silent second or something like this, in order to avoid that this is of course that should be silence. This is comparable to any list or to padding. Actually, we are padding, but here we are padding with some silence in terms of audio stuff. So So here, what we also need to do is, of course, to let's say see if we have a text or not, and if not, we will also print additionally to actually the use case where we said that ChatGPT should be aware if there is no text, it shouldn't say anything. This is also yeah, we need some silence, empty empty translation for segment I+1, and inserting the target duration of the segment, millisecond of silence. Then we also need to combined plus equals audio segment. Then we need the silent duration equals target duration in milliseconds. The previous end equals to the end, and we continue. Okay, so this is so far so good. We have treated both use cases. What else should be considered? So now we print now we can print F synthesizing sizing segment, let's say, for example. Okay, so this is out of the loop, which is wrong. This is my first mistake, and this also should be within the indentation. And this is, of course, I+1, and we got here the text. So this is to know where we are moving, let's say. Then here comes now the heart of the method, which is temp file and used speed equals to, now this is what we are basically returning from this method. And yeah, this is a generate TGS with dynamic speed, and we got text equals to text. We got also voice ID equals to voice ID, and the target duration in milliseconds equals to target duration in milliseconds. Then what we got also is we can basically print for debugging, for showing where we are, print F segment I+1 fits at speed used speed that 2f, and except, of course, we need to accept exceptions, runtime error as e. And here what we got is to print the f, I mean using this f for inserting our arguments, we have this error, for example, and inserting silence instead. Silence instead. Why? Because if any problem occurs, we can't afford to lose the duration. The whole duration should be at least not far away from the target duration or the original audio duration. So this is why if anything goes wrong, and it is, as I told you, very expensive to try a lot. This is why I'm using this setup, and it depends on the use case. You can invest more credits to test and see what how to treat all single use cases, or let's say all occurrences within this setup. For me, this has delivered very good results. And yeah, segment audio then is equal to audio segment, then from file from MP3, and let's say this is the temp file, and of course okay, so this is another pad. Why? Because now we are dealing with a generated temp file, and in the end we can we need to actually compare the result with the awaited segment length, and here we can also okay, so here we can either use actual duration length, or also have used the other method. It's up to you. And we need to compare here now if the actual duration is less than target duration in milliseconds. What we need is to pad equals to the audio segment dot silent, and the duration is equal to let's say target duration in milliseconds minus actual duration. Then what we got also is segment audio plus equals pad, and this is it. Then we will print to debug and to see where we are moving, what step are we having. Segment r plus 1. Then we also have the target, which is equal to the target duration in milliseconds, and we also have the actual equals to length segment audio in milliseconds, and the combined should be plus equals segment audio, and we will remove the temp file. Also previous end equals to the end, and this is, in my opinion, now we are dealing in this we are so far handling everything in this for loop while treating each segment one by one. And in the end, we also need to combine the final everything. So we need to print again final combined audio duration. Here we got the length and of the combined. We divide per 1000, and here we got the seconds, and combined dot export. Combined is of course an audio segment instantiation. This is why export, and we got the output audio, and we also get the format, which is MP3. Then for this sake we will use F here, and final audio saved to the output audio. This is pretty much the idea, and I hope that this is clear enough. Now for this part we are, let's say, almost good to go. What is missing is of course to create something like cloning the voice. So we need to actually clone the voice, and in order to be able to clone the voice, we actually need to here create something which enables us to extract some voice sample. We will just write some helper function here, which is called clone voice dot py, and for this we will again use from ElevenLabs that client, and import ElevenLabs. We also can import the OS, or should, and we need the .env, also import load.env. Here let's declare this. Then what we got is ElevenLabs 11labs API key equals to os.getEnv. And here again we will get this copy pasted inside this one, and client equals to, of course this is declared 11labs, and now we got the API key equals to 11labs API key. We also this is pretty much it. I mean, we need to actually extract this, and then of course we can extract a sample of 60 seconds. Extract voice sample, and this should have the video path, which is for now empty. Actually we can use some typing, but I just need to make it quicker. And now we got also the output audio, and which is empty also. Then we can define duration of 60 seconds. We can also define 30 seconds. That's more than enough. Now we are actually extracting. We need a command. We will use FFmpeg. We will just write the parameters of the command, and this is so these are the commands as FFmpeg, comma -y, and this is also -i, video path. Then we got also the -t, and the string of the duration. We also get these parameters, which I don't personally master, to be honest. And if you tell me what this means, I can tell you honestly what. But nonetheless, this worked very good for me. And the goal here is to know how to deal with each part of the code, and how to use this in order to get the big picture or to reach the goal. So this is how I treat such projects. And now subprocess, I didn't import it, so import the subprocess library. Then we will run the cmd, and we will check equals true. Moreover, we can just debug and say print extracted voice sample to this output audio. Once we got the extraction as we want to, we can now upload the voice sample to the API, and then get in return the ID, the generated ID def upload voice sample, and this is you need the voice name, the audio file path. We have also the description cloned via automation, for example, and the response. So response is equal to client.clone, and here okay. Let's see why this didn't. ElevenLabs.client. ElevenLabs. This is a little bit not clear. All right, so it looks like the documentation has changed in a while. So this is what I've got in their GitHub voice clone means voices.evc.create. So this is something probably new. I didn't check with a probably newer version or any update that I didn't check. So let's try this out. Voices.evc and then create. Name equals, let's say, tutorial equals tutorial. Then what we've got also is something like this. We got the description equals yeah, let's name it here voice name. The description is the description. And what we also got is the files equals to the audio path file like this. I think we are good to go. What we also need to have is in the end print something, and let's say f then voice. We got our voice name here cloned, then the voice ID. Here we got response that voice ID, which is very important. And then we will return the response that voice ID. So I think this is it. We can try this if name equals main. Let's say in the first step, extract voice sample. We got our video path equals to extractions, and what we've got is downloaded video.mp4. We got also next argument is the output audio. Output audio is segment, or let's say sample.mp3. Let's put it also in extractions. That mp3. We can moreover upload voice sample here and get back, of course, what we actually need is the voice cloned voice ID is equal to this one, and we need the voice name. Let's name it tutorial. Then our audio file path, which is this one, and we can also use the description here, and yeah, let's use the same and keep it simple. I can also ignore this, but let's keep it just like that, and then print, of course, print the cloned voice ID, and let's do it. So this has worked, uh, but this one didn't work. Okay, so this is something which is okay. Your subscription has no access to use instant voice cloning. Please upgrade. So my subscription doesn't have access to. So this is also actually called instance voice cloning, which means that I need to find another way to solve the problem, because what I've noticed that I couldn't use client dot let's do this clone again. It disappeared. Could maybe be uh, the version issue. Let's solve this. So it turns out that my subscription has ended. What I've done is I found out that this version doesn't have the clone function or method. So I've downgraded to a later version, which is previous version, which is 1.58.1. And then although changed the method, I found out that actually my subscription was ended, and since then I need to actually do it again. Now this should be working. All right, so let's make a useful update. Actually, I have bought this creator subscription, which is this one. I actually normally should have cloning voices of custom voices. I do have 30 voices per month, but it says that I have reached 41 over 30. You can upgrade. I can't relate to this. So I don't know what's happening with ElevenLabs. I will try it the next day, but this is it. This is at least the state of the, let's say, state of art. Um, this has been said, we will proceed in the next steps without cloning voice in order to just make it happen. But you got the idea. This is something which is actually straightforward, and you can use it whenever you want. If you want to clone your voice, if you have some subscription, etc. So feel free to ask questions, to write in the comment section. And of course, if you need anything to help solving the issue, don't hesitate to write in the comment section. For me, from my part, I won't use more than 100,000 credits for my case. That's why I want upgrade again to have more custom voices. I don't need it at this level. But this gives you at least an idea about how the pricing also works. And you can actually, as I know, even contact them. I guess this is something that one could use. And I don't know if they are reachable via email or anything like this. But anyway, this is something that you can use. And there is also the professional voices, voice cloning. You have one in the subscription, and this lasts. I think you need 6 hours of voices, and this lasts, I guess, one day or I don't know, and they need to contact you via email to confirm that your one professional voice cloning has been successful. This being said, we will end this part at this level, and in the next parts we will see how we can actually combine the extracted video um, and the extracted audio with the old video. So for this we will generate the text to speech in the target language, which is French, and then see um, how to integrate the new speech into a video. Thank you for watching this, and don't hesitate to comment, to write your ideas in the comment section below. Subscribe to the channel, and thank you again for watching this tutorial.